Hi everybody, so we're on section 3.2, video number 2. We are going to extend that corresponding angle postulate. Now remember, of course, the corresponding angle postulate says that if two parallel lines are cut by a transversal, then corresponding angles are congruent. Corresponding angles are congruent. I love congruent because it means they're equal. All right, so how can we use it? So we're going to use that postulate to prove something about alternate interior angles. Now remember, alternate interior angles are angles that are on alternate sides of the transversal and on the interior of the two lines. So number one, I was given that K is parallel to N. So I'm going to mark my diagram with my given. Most important thing, mark diagram. Okay, so I've marked my diagram with my given, and I'm trying to prove, and I put little dots there, I'm trying to prove that 1 equals 2. All right, so in order to do this, I might have to use the corresponding angle postulate. Now remember, we always put our statements on the left, our reasons on the right, and I prefer you using those proof sheets I made for you, but if not, you do it on a piece of paper and you make it really neat. And we're going to start with our given. Now, we've only learned one thing that we're allowed to say if we have two parallel lines and they are cut by a transversal. We are allowed to say that angle 3 is congruent to angle 2. Well, why are we allowed to say that? What kind of angles are 3 and 2? Well, 3 and 2 are corresponding angles, so we know they're congruent by the corresponding angle postulate, also known as CAP. Okay, the corresponding angle postulate. All right, but now I'm trying to get 1 equaling 2. Well, hopefully you're seeing that you know that 1 and 3 are congruent because of the vertical angle theorem. So I'm going to mark 1 and 3 congruent. So angle 1 is congruent to angle 3 because of the vertical angle theorem, which says that which says that vertical angles are congruent. Now, this is where game time. This is where we're in game time, guys. Look, 3 is in both of these, and I'm trying to somehow connect 1 and 2. So I can do it by the transitive property. Remember, when we're trying to connect angles via other angles, then that's a really nice way to see the transitive property, like substituting things twice almost. So angle 1 is congruent to angle 2 because of the transitive property of congruence. All right, so what did we just prove? Well, what we just proved is that alternate interior angles, if two parallel lines are cut by a transversal, then also alternate interior angles are congruent, and that's called the alternate interior angle theorem. So if two parallel lines are cut by a transversal, then alternate interior angles are congruent because of the alternate interior angle theorem. No shortcuts. Alt int angle theorem. Okay, alt int angle theorem. All right, let's look at an example from algebra. Okay, now remember I told you that sometimes the parallel line symbol is kind of funny. See how it's like a triangle? That means that these lines are parallel, so that makes this line my transversal. So I notice that these are alternate interior angles. So to use algebra, I can write an equation. First, I'm going to mark my diagram with the angles congruent. So then 80 equals 2x. 80 equals 2x. And then I divide by 2. And so x equals 40. All right, guys, so that's your video on alternate interior angles, one of my favorite theorems. Talk to you soon. Bye.